Hello, everyone. My name is Mik. I'm from National Taiwan University. I'm representing my group to present figure-based productivity monitoring of worker and large-scale object interaction in construction sites. So, automating productivity monitoring is crucial right now. As we know, construction industry always lag behind other sectors. But to measure the productivity, we have to understand three things. We have to know the workers, we have to know the object, and we have to know the action simultaneously. And right now, the current issue is we lack information about this interaction between worker, object, and their action. So the manager cannot measure the productivity properly. So it's crucial right now to understand the interaction between human and object in construction site. The existing vision-based studies focusing only the worker detection. We have many research about worker detection. We have many research in object detection. We also have many research in active detection. But they haven't gathered them together to get valuable information for productivity monitoring. So human object interaction can help us to join this research together for a productivity monitoring process. So our objective is developing the automated system for productivity monitoring to detect the interaction between workers and objects and then classify them either productive and non-productive actions. Okay, but basically we have a three-step here. We use a graph-based system. First, we from the video that we get, and then we extracted in several frames, and then we do the object detection first. Since this is a graph, we have to provide the node information first. We use a faster RCNN to detect the objects. For example, in here we detect a human, we detect the rebar, we detect the formwork, and we use that one to for as a node information. And then in the step two, we use a graph attention network to generate the interaction between human and objects. And we use the features such as a visual feature, spatial feature, and also semantic feature. Once we have the interaction, the next step would be activity recognitions. Yeah. So what kind of action for worker with the formwork, action with the rebar, and so on. And we prepare 4 action here. We have a transporting, preparing, and installing, which is the productive action. And the last action is no interaction, is non-productive actions. And for to begin the experiment, so we got a video surveillance, and then we extracted in 1250 images, and then we do the annotation. We have a 6-step here. We throw the human box first, and then we throw the object pointing box, and we put the action ID there. And we have 3 classes. We have a human, we have a formwork, and we have a rebar. And then for the next experiment, we also consider the global area of the object and local area of the object. A global area means the big size of the object, and local area is the small part of the object that has a direct interaction with the human. And then we also classify the action with the productive and non-productive, as we mentioned before. And then as the inference result, the first inference result, we not only detect the big object one, but also we can also detect the small object one. In here we have a human one or HO interact with the formwork local. He's installing the formwork. And then for the second result, we detect some object there. We have a formwork, we have a rebar, we have raw formwork there, and then they are doing the preparing the formwork in a major activity. And then for this person, for this image we detect two workers, and then the front worker one he's working for the transporting the formwork. Yeah. And this is the number of the total detected action for the whole workers. This is the preparing, transporting, and installing. We got a high, high action. However, the no interaction part is also high. This one should be considered by a project manager and should be addressed to improve the productivity of the workers in the future. And this is our performance result. We use a MAP scenario, and we got a 63% of the MAP, and then we slightly higher with the current model in the HOI domain. Yeah. However, we have some limitation here. We only rely on the static image, and because of that, so we might not get other potential feature like a temporal feature. We haven't considered it, and also the post feature. We will also haven't used it. And as a surveillance video, it should be we capture the images from the long distance, not in the close up distance. So for future work, we will consider it to capture. I mean, we use the case study that have a small size of the object, so we can be more field applicable in the future. So for the conclusion, we have successfully detect the interaction between workers and the objects. Basically, we want to know which worker are working for what object. That is our issue. We have successfully identified it, and then we reach a MAP score 63. Even though we have such many limitation and yeah, that we have to address in our future study. And this output can be can support the daily consumption report, so we can support the manager in preparing daily consumption report and also quality control and decision making. Yeah. Thank you for your attention.